Hello, everyone. My name is Elena, and I was working on this unit for, like Daniela said, about 2 years. In this unit, we focus on the role of carbon dioxide in the climate change, and especially in the greenhouse effect. The topics that we are going to cover in this unit, like I said, is about carbon dioxide, the greenhouse effect, the acidification of oceans water when the carbon dioxide is absorbed in the oceans. And we will also try not only analyze what the problem is, but we will also try to find some solutions. So the goals that we are going to cover are goal number 13, climate action, and number 14, life below water, and number 7, affordable and clean energy. The age of the students, it depends on their skills, and depends on the country. You know your students better than anyone else. So, but we think that it could be applied with students from 12, 13 years old up to 16. And at the end of the unit, you can also carry out cooperation activities with other schools in your area to compare the carbon footprint or to come up with ideas to deal with this problem. This unit is divided in different sections. You don't need to follow each single section of the unit, so you can just go directly to the one that you think is better for your students. You don't need to cover all of them, or you don't need to follow the order in which the unit is presented. But the different sections in the order that we think is the best is, first of all, to introduce students about the civilization of carbon and the different sources of carbon dioxide. Then we recommend to cover the greenhouse effect and the increase in temperature due with the excess of carbon dioxide in the atmosphere. Then, after covering the greenhouse effect, we think it's good to analyze how the carbon dioxide can be absorbed by the water and how that absorption can turn into an acidification of the water in the oceans. And finally, after analyzing all the different problems, we encourage students to come up with a solution. That's why the title of the unit is Think Global and Act Locally. Okay. The first part of the unit is to activate the background knowledge that students have about carbon dioxide, because it's in the news, it's always on TV, in the newspapers, and they have probably studied in primary school about carbon dioxide, so they know a lot about this gas. So we recommend to start with a quiz to find out how much they know about this gas. Then our first section is the civilization of carbon, and to analyze the different sources of carbon dioxide. In this section, we will start with an interactive documentary activity that it was developed with H5P. So students not only can watch a video, and realize some key facts about this gas, but also answer some questions that will be posted through the video. The unit, this part of the unit also comes along with some chemical reactions and also different activities to model these chemical reactions and to teach them how to balance them. This is an image of what I was telling you about the interactive activity, the video where we expose them to key facts about carbon dioxide, and they have to answer a few questions that come along with the video. About the lab activities in this section, they have to do with combustion reactions, since carbon dioxide is a gas that is expelled in combustion reactions. So one of the activities has to do with the combustion of carbon, another one with the combustion of methane. And through these combustion reactions, we propose a way to identify the different compounds that are involved in these reactions. So it's not only carbon dioxide, which can be identified with lime water, but also we propose to identify also that water is a reaction product in this type of reactions. So all the information is posted in the website of the project with the different resources to carry out the different lab activities. They have their protocols, videos, images. So I think they are very, very well explained. This part was done and tested by my colleague Philippe from France, and I really think he did a great work. After carrying out the lab activities, you can use a website that you probably know from Boulder University in Colorado. This website has lots and lots of different simulations, most of them about physics, but there are some of them about chemistry. So they can model the different chemical reactions, how the atoms join, and how to balance the mass of the chemical reaction. So you can use this simulation to explain Lavoisier's law, or the law of conservation of mass within the chemical reactions, which I suppose in most countries is covered in secondary school. So at the end of these sections, students should come up with the idea that humanity has always burned something for energy purposes. So we usually burn carbon or resources that come from fossil fuels. And with these activities, we increase the amount of carbon dioxide that is expelled in the atmosphere. So that should be the outcome of this section. This is the main idea for our students to come up with. Then there's another section which is about the greenhouse effect and temperature. And in this section, our goal is to prove that carbon dioxide is a greenhouse gas and that it helps increasing the temperature of the air. So we will try to show what a greenhouse effect is and how scientists link the increase in temperature with the increase of carbon dioxide in the atmosphere and with the combustion reactions that we will study as well in this section and that were studied in the previous one as well. Now, in order to cover this section, we will use some lab activities. We can program different sensors, and we will also model the greenhouse effect. First of all, we show some interactive activities, and we try to teach our students what the I-score analysis means, what these pieces of ice mean, and what they have, and what they can show us about the history of the atmosphere and its composition. So we can compare from different periods of time how much carbon dioxide we had, and there are some data about the increase in temperature according to this amount of carbon dioxide. So we will show them some graphics where they can analyze and realize how both magnitudes are depend on each other, especially when the amount of carbon dioxide suffers an increase, then the temperature of the air increases along with the carbon dioxide concentration. Okay. And but besides that, we tried an experiment with them to simulate this situation at the school in the lab. So what we did here was to use two different jars. In both of them, we placed the same amount, the same volume of water, and two temperature sensors. We use the DS18B20, which can be submerged in water, and we also use a sensor to measure the amount of carbon dioxide. One very inexpensive sensor is the CCS 811, which works very well and it's not hard to use. We used Arduino Uno as a microcontroller, but you can use some other types if you want to. It doesn't have to be with Arduino Uno. We use an LCD to show the data of the different measurements. And we also used a lamp that releases heat to use the lamp as a simulation of the sun. So the lamp plays the role of the sun, and in the two jars we have, like I said before, one temperature sensor and a CO2 sensor. We cover the different jars with a plastic film, and we use a rubber band to make sure that the carbon dioxide cannot escape from the one of the jars. So in one of the jars we just have plain water, but in the other one we added a few grams of some chemical that will produce carbon dioxide. In our case, we tested different ones, and we like the one with the fruit salts that is used for stomach aches, the Epsom salts that are very inexpensive. They work very well for this experiment, because actually that reaction is an endothermic reaction. So even though it's endothermic, at the end of the experiment, the temperature in that jar is much, much higher than in the other one. Like I said, the same amount of water. In one of them, we will produce a chemical reaction that expels carbon dioxide, but not in the other one. And we will continuously measure the temperature in both jars, as well as the amount of carbon dioxide. Now, about the carbon dioxide, you have two different choices. You could either use two different sensors, one for each jar, but you can also use one single sensor, because you can measure just at the beginning the amount of carbon dioxide in the jar where you are not going to produce any chemical reaction. And that should be constant throughout the experiment, because you are not producing any carbon dioxide. So if you want to, you can just go ahead and use one single carbon dioxide sensor. So you test at first with the 2 jars open how much carbon dioxide you have in both of them, and the most common value is around 400 ppm, which is the normal amount on air. And then you place the carbon dioxide sensor in the one where you're going to produce the chemical reaction, and then you close very carefully the 2 jars. So just to make sure that no gas is released out of the jars, especially the one in which you're going to produce the chemical reaction. About the coding of these sensors, it is quite easy, and depending on the age of your students, you can use block coding. The one that I'm showing here is with Arduino blocks, but you have lots of different options. We use Arduino Uno with Arduino blocks, and we show the data through an LCD as well as through a serial port. But you could also send through a Wi-Fi connections. I will explain at the end a little bit about how to send the data to the internet or to a website. The good thing about that is that you can share with different schools, you can exchange the data, and it can be seen, in live. You don't need to wait, okay? So as soon as it's recorded, you can see it through the internet, even at nights when you are at home. So it is something that is quite useful. And that way you're using also the Internet of the Things in case you need to teach a little bit about that in your schools. But of course, you can also use text coding if they are used to code in Arduino. This is an image of some of our outcomes. As you can see in this slide, we're showing that the amount of carbon dioxide in the jar with the chemical reaction is almost 2,000. So it increased from around 400 ppm up to almost 2,000. And here we're showing the difference in temperature. In the one without carbon dioxide, the temperature is 27.5 degrees Celsius, while in the other one is 34. Now, this is not the final outcome of the experiment because it increased a little bit more than this. And to get these values, it took us less than 9 minutes. So the experiment runs really, really fast. Actually, you can record the data without the chemical reaction, and they can see that the amount is constant, the temperature doesn't change in neither of the jars, or very little, or about the same amount in both. But then when you release the carbon dioxide, then the difference is about 10 degrees in around 9 minutes, not even 10 minutes. So they realized that what they saw before in the different graphs, it can be proven in a lab experiment, how the carbon dioxide increases the temperature. As you can see in this image, we got 27.6 in the one without carbon dioxide and 37, which is almost 10 degrees higher in the jar where the chemical reaction was carried out. And like I said, the amount of carbon dioxide that we reached was around 2,000 parts per million, while at first on the air it's around 400. So it increases a lot with very little amount of chemicals. Then we covered oceans acidification, because once that the students realize that carbon dioxide is expelled in the atmosphere, we wanted to teach them that the carbon dioxide not only stays in that atmosphere, but that it also, from the atmosphere, it can be absorbed, and actually it is absorbed by the water from the oceans, rivers, and so on. Any water that is in contact with that air. So our goal was to prove that combustion reactions release carbon dioxide and water. And here we offer two different levels of experiments depending on the skills, the coding skills of the students, and the age of the students, of course. We propose a level 1 experiment where we just burn a wooden stick on top of seawater solutions that they brought to our school, and we added some indicator in those solutions. So just we burn them in an Erlenmeyer flask where we had those solutions, and then we put a stopper after the flame went off. We placed the stopper on top of the Erlenmeyer flask, and just we waited for a few minutes, and it looks like nothing is going to happen, because actually nothing happens at first. But then after a few minutes, and this experiment you need to be careful because it takes a few minutes to see any difference, any outcome of this experiment, because the absorption of gases is quite slow. So that also gave us the chance to show that the absorption of gases in water is not a fast experiment. It's something that happens at a slow rate. But that actually at the end it will happen. So this is what our Erlenmeyer flask looked like while we were burning the wooden stick. And here we use Bromothymol blue as an indicator, but we also tested with a red cabbage indicator that the students can make at the school, because it's something that we can buy at the stores, a red cabbage, and they have, if the younger students, they have quite fun making that indicator in plastic bags. So you can use any indicator that works with the range of pH that we are going to have to deal with. This is just to show you the different colors of this indicator, Bromothymol blue. So as you can see here, when it is blue, it is a little bit higher than 7, and when it turns kind of yellow or green, that shows that its pH is below 7. So this is what our liquid looked like at first, using Bromothymol blue. So you can see the blue color and how much liquid we use. You only need a little bit. And this is our Erlenmeyer flask at the end of the experiment. Now, if you remember from the previous slide, that green or yellow color shows that the pH of the water sample has decreased. So we have an acid in that solution. We first waited until the color changed, and it took a while, like I said before, and then we repeated the experiment, shaking the Erlenmeyer flask, and you can see that the color changes much faster. Now, by shaking the experiment, we are showing that the waves of the ocean, they can also accelerate this process of absorption. And so while shaking the liquid, we are trying to simulate the waves of the ocean. How those waves and the wind can accelerate the absorption process. We also try something similar, but a little bit harder for all the students, and we call that level 2 experiment. So we try to do something similar, but this time we using sensors and coding those sensors. So let me show you what we did in the lab. We still have the Erlenmeyer flask with the Bromothymol blue solution, the water sample, that in our case, since we live close to the coast, it was brought by our students. And we have here you can see the flame on top of the water, on top of the Erlenmeyer flask. So we are burning a wooden stick. But on top of the Erlenmeyer flask, we have an upside down funnel. And in that funnel, we placed two sensors. We placed a CO2 sensor, the same one that we used before, and we also placed a humidity and temperature sensor. So that way, we are measuring the amount of carbon dioxide throughout the reaction, the amount of humidity, which is going to make us think about the water that is produced in the combustion reactions, because if water is produced, we should not only see the little drops of water in that funnel, but also the sensor should record how the humidity is increasing. And of course, you can also record the temperature throughout the reaction, since it is an exothermic reaction. So here you have in this slide just a list of the different materials that we decided to use. You can also see the Arduino Uno that we used. So all the sensors that are, well, the two sensors that are inside the panel, they are connected to the Arduino Uno, and that microcontroller to our computers. So we decided to use the DH222 humidity sensor. So that is the setting for our experiment. Now, once again, you have different options here depending on the computer skills of your students or on their age. You can use block coding. Here we also use Arduino blocks, but you could use any other platform that uses blocks. I have also tested with microbit or with other microcontrollers. In the case of microbit, you may have to use the different extensions for the different sensors, but it works very well as well. And if your students know how to code with Arduino, then you can use text coding, of course. Now, in the materials that we added to this unit, we are providing you with the text the text coding, so you can really copy and paste, okay? Because it is done for you. I'm not showing it here. I'm showing you the blocks, but the text, which may be a little bit harder, it is in the website of this project. As well as different worksheets that you can provide to your students. So they should come up with a similar idea that CO2 increases throughout the experiment, which will prove that it's a product of this chemical reaction. The humidity sensor should record how the humidity increases So that also explains that water is produced in the chemical reaction. And with the indicator, we will prove that carbon dioxide reacts with water and produces carbonic acid, which decreases the pH of the solution. If you want to, we did, but it's up to you. You can use either an indicator to show that, or you can measure the pH. You could use a pH sensor connected to the Arduino, or you can use a pH meter. Now, about oceans acidification, it is important to notice not only that the pH decreases, but also to study how that affects some living beings in the ocean. We analyze how this decrease on the pH affects the seashells. We took the 4 different seawater samples with different pHs because they came from different places. Now, in our case, we were lucky because we live very close to the coast. So our students used to travel to different places where they can collect these samples. If you don't have that chance, you can also create different samples in your labs with different pHs, and that way you can model the sea water. So what we did was to measure 2 grams of seashells, and we placed 2 grams of these seashells in each of the water samples, and we left them there for a week. And after a week, we measured the mass of those shells, and we tried to relate the decrease in the mass of the seashells with the different pH in the different solutions. So the students should come up with the idea that the lower the pH, the higher the decrease in the mass of the seashells. Here you have, we used 4 different samples with 4 different pHs. You can use as many as you want to. It is really up to you. So we have different seawater samples with in each of them the same amount of water sample and the same amount of seashells in order to be able to compare. So we wait after being submerged for a week. Now you can also change that. You can submerge the samples for longer than a week. There was a teacher who had the water samples for 4 weeks, but for us it worked better for a week because we have a science club and we see our students every week, once a week. And then we asked them to think about how we could try to solve this problem. And what we did was they proposed to use to collect some seashells from the beach and then smash them and use them, add them to the water samples. So maybe to use that as a buffer solution. And we did, and it worked very well because we use, in this case, red cabbage indicator. And in this slide, you can see that the one with the blue color, it has at the bottom of the water sample, it has some seashells that were were smashed in smaller pieces. So the pH hardly changed, but in the one without those seashells, then the color changed, showing that the pH decreased. And finally, the final part of this unit is how to solve the problem. So here we have different options as well. We propose to produce hydrogen and to use hydrogen as a source of energy. And to produce hydrogen, we carried out different lab activities. We decompose water using electrical current to produce hydrogen. And we also use a fuel cell to calculate the energy that was produced. Now here you have different activities that are with the different resources that are in the website of the project. You can run a car using a fuel cell, different activities, but the goal is to ask your students to propose some solutions. Our students came up with this, but maybe your students come up with some other solutions. And also at the end, we try to make our students think about what we can do at a local level to decrease the amount of carbon dioxide. So these are some ideas that students from France with Philippe came up with. They proposed a walk to school day or a back to school day, also to reduce the street lighting. They also have different meetings with students from different schools that are very close to them, and they try to come up with common ideas and to test different ideas to reduce the carbon footprint between schools. And like I told you before, in case you work with schools around you, you can share your data using ThingSpeak, which is, I find it quite useful because you can see in real time the data from another school that is placed in France or in Italy. You can compare with your own data from your own school, like I said, at real time. So in order to share data with different schools, I think it is quite useful. Now you can use ThingSpeak, you can code it with Arduino blocks. It's quite easy also, and there are different tutorials that will show you how to do this, or with text coding as well. Here I'm just showing you some of the blocks that Arduino blocks provides for you in order to use ThingSpeak. So it's just a couple of blocks that you have used, and of course you need to write down your ID, your channel, so some private information. That's why I'm not showing here just where you see the XXX. You have to use your own private information from your own channels. But I think it is worth it to give it a try, because it is important to share data in real time if you're going to do something with schools from different countries. And just finally, thank you very much for listening and for your attention. Thank you so much.